Hi everyone, welcome to our Generative AI Bootcamp series. Today we will be discussing how to use generative AI to enrich your current products and develop conversational experiences by just using natural language. Let's start with introductions. I'm Drishti. I'm a customer engineer at Google Cloud, specializing in generative AI and machine learning. I have been in the industry for a decade now and have worked with small, medium businesses to Fortune 500 across industry segments like retail, healthcare, media and entertainment, manufacturing, etc. I am very excited to be here with all of you today and to help navigate paths on how to democratize AI. I will be covering the different paths that we can take today in how to, start extracting value with Gen AI, with large language models, and what are different ways that, even you can start doing it today using the GCP console. So let me pass it along to Anjali for her introduction.
Hello everyone, I'm Anjali and I'm a strategic cloud engineer at Google working at contact center AI and generative AI. I have been working with customers across different segments as telecom, finance, manufacturing, retail, etc., helping them with their AI journey and accomplishing their business requirements and enhancing customer experience with AI. Very happy to be here and looking forward to the great session together. And I'll be taking through retrieval augmented generation, which are patterns helping LLMs be grounded in factuality using something called as information retrieval systems. And with all of this context, I pass on to Drishti to get started.
Thank you, Anjali. All right. Before we start diving deep into the session today, I would like to mention that this is a bootcamp series. So we already launched a Gen AI 100 level last month, which covers, foundations of large language models, what they are, where they come from, how are they developed, and the idea of the new skill that we are developing right now, which is how to write prompts in order to extract proper information and proper value from the LLMs that we have. So I would highly recommend for you to go through this. And with that, let's dive into the session today. Perfect. So at Google, when we are thinking of making generative AI technology accessible to everyone, the underlying thought process comes from two perspectives: consumers versus enterprise. The use cases, concerns, priorities are very different when it comes to consumer and also when it comes to an enterprise company. For consumers, we have launched BART, which is a conversational chatbot that uses human language or natural language to generate results by understanding the question or the prompt and the context behind that question. It is based on a large language model, which is called Lambda. The full form of that is Language Model for Dialogue Applications that Google developed in 2021. Let's go through some examples that, what our consumers have been asking Bard, some of which are, plan a 3-day trip to Patagonia, or how do you make pancakes? Now, the success criteria for a consumer at this point is the brevity of the response in less time and with accuracy. But thinking about data sovereignty, security, authentication, fraud, access of proper information to proper people in the organization is not of concern. But when you start thinking from an enterprise perspective, all these things are top of mind, and the first things that and any enterprise would think of before they begin incorporating any new technology. The second biggest thing that they start thinking of is that even if there is a new technology that is out there in the market, how do you integrate that with the current infrastructure? So that's why we have come up with different products and services when it comes to consumers, when it comes to enterprises, and we are working with our teams and the entire development teams in order to launch those specific products so that our customers can actually start extracting value with Gen AI. So, like Lambda, for enterprises, we have trained specific large language models for specific use cases. We don't believe that one shoe fits all or the answer to all requests, whether consumer or an enterprise, can be one big LLM model. So what you see here in the slide is our different offerings of wide variety of LLM models of different modalities and tasks. For example, Palm for text and Palm for chat, Palm being the name of the LLM model, is specifically used for tasks like content creation, summarization, and for multi-turn chat conversations. I'll give you a quick example. Say, for example, you write a prompt or you write a question to Palm for Text saying, summarize products and services that my company provides to a VP of marketing in a healthcare industry or in a healthcare company. The LLM model will be able to generate that content, will be able to generate that email in that tone. Versus if you change the prompt or if you change the question to write a summary of your products and services to a VP of IT in the healthcare department, it will be able to tune that, it will be able to tune itself and change the response according to that. Now, the responses are also multi-turn. The conversation with the LLM model is also multi-turn. The more questions that you ask, it will keep understanding the context of the question. It will keep rebuilding its answers, and it will keep tuning itself based on the questions that you are asking. It will be, and also there is a feature there that you can give real-time human feedback that the responses that it is generating, how creative it is, how accurate it is, and what features you want to add and what features you want to remove. There are multiple options that you can choose from there. Another model that you see here that we have for you is Imagine for text and image, for text to image. And as the name suggests, what it does is that if you input a text, it will be able to generate an image for you. Capabilities of watermarking, what to include in the image, what not to include in the image, and how to edit the image are there for you for your use. Similar to that, we have Cody for code generation and code completion that can be very useful for application developers. And there are some embeddings API which are available for downstream machine learning tasks. Beyond the choices that we are giving to our customers of different LLM models, and these 6 LLM models are right now available. They are in GA. We have more upcoming, which are in the roadmap that we are going to keep launching throughout the coming years. So beyond the choice that we are giving of different LLM models, you have built-in safety and security. You have built-in thought of data governance and data proprietary, and all of this is running on the enterprise-grade infrastructure that Google Cloud provides. So Google has been a pioneer in machine learning and AI for decades now, and we have curated products that meet our customers where they are in their AI and machine learning journey. Vertex AI is the underlying platform on which machine learning and AI products are built for different use cases that the enterprises might have. All these products are deeply integrated with Google Data Cloud and runs on the Google Cloud infrastructure with different GPUs, TPUs options that we provide. That being said, what you see here in terms of AI solutions, some of these solutions have been in GA for years now. For example, our contact center AI solution or our document AI solution. What we have done is we've taken the capabilities of the large language models that we provide and we have enriched those GA products as well. So now if you start using our contact center AI, you will be able to use the Gen AI features which are available in that. And similar to that, even document AI. Search and conversation, the two products that you see here today, that you see on the slide, are going to be two products that we are going to focus on. I'm going to go through demos of that as well. And you can see how easy it is to start utilizing those features and those products with minimal amount of development effort. One thing I did want to cover is the model garden. And what that is, it is a single glass pane which has all the large language models that Google has created and hosts, and also all the LLM models that we have partnership with, for example, Anthropic and other models out there. So different products within that Vertex AI portfolio can be used for different personas in your organization. For today, we would be focusing on the products that are used for embedding the models into the current features that you have, into the current product that you have, and also how you can consume these models. That being said, when it comes to embedding of models, we are going to be focusing on the search and conversation product and how you can use those products to start seeing value of Gen AI in today with minimal amount of effort. And then on the consumption side, how your different cloud users, whether they are application developers, whether they are security officers, whether they are cloud admins, can improve the productivity using a product called Do It AI. All right, perfect. So now let's discuss more on Vertex AI search. What Vertex AI search is, it is Google search, but for your internal organization. It is powered by large language model. And what it can do is you can use natural language question, and it is going to be able to output summary with citations of the knowledge discovery that you are wanting it to do. The responses of that are going to be grounded in factuality based on the corpus of corporate data that you provide. Now, what does my last three sentence mean? What it means is that you will be able to create a data store, and that data store can be of multiple types. The data store can be a list of web pages or websites that you have, public or private. The data store can be structured data, which is in your, say, Cloud SQL, or it can be unstructured data, which is, say, a list of PDF documents. The structured data can also be in BigQuery, which is our data warehouse. Now, these are different type of data stores that you have, and you can simply connect that data store into with enterprise search or Vertex AI search. And it will be, and after that, using Vertex AI search, you will be able to ask questions in natural language, and it will be able to give the answers to you. Now, how is this helpful and how is this so powerful when you're thinking from a generative AI perspective or a large language model perspective? Number one is, until now, to do any sort of machine learning, data analysts had to go through multiple rounds and iterations of first getting the data ready. They had to get all the unstructured data. They had to clean the data, process the data, make the data available, so that right amount of machine learning results can be attained from them, whether it was recommendation, classification, or prediction, or any sort of use case that we had. But thinking of enterprise search, you can skip all that step, all that effort and time that is required. You can simply take all your PDF documents, whatever kind they are. You can upload them into cloud storage, which is our blob storage, and connect that to enterprise search. And it will be able to go through that, index those documents, get the relevant answers that you are looking for with citations and summary. And this is the power of Vertex AI search. We have also launched something called data connectors and extensions, which can directly connect to your third-party backend systems, for example, Salesforce. So say if you have Salesforce as your CRM system and it has a large amount of data, a lot of times it is very helpful to have like a corporate enterprise search on top or a Google search on top to just search for in natural language, and something that gives you very accurate and brief responses, traversing through entire Salesforce data. And this can be really helpful, really powerful for the entire organization on your side. Now, talking about Vertex AI Conversation and what that essentially is. Vertex AI Conversation, or what we call it as a chatbot or infobot, the same chatbot and infobot can connect to the same data stores that I just talked about in my last slide. The data stores can be of three types, whether it is websites or web pages. It can be structured data in your in your Cloud SQL or BigQuery, or it can be unstructured data sitting in cloud storage. What Infobot does is it provides a very conversational experience. It can understand context, it remembers context, and it is able to do some tasks that required human intervention in the past, like scheduling an appointment, or giving you a summary, or giving you direct links to where particular information is present. So to give you a summary of the capabilities that it has, as I said, it is very informational. It can basically, you can ask a question to it in natural language. It will be able to use the natural language, create, say like for example, if you are looking to get an answer of, say, average of 10 numbers. Now that information is present in BigQuery. And if you're looking to kind of get an information on what the average of those 10 numbers are, you can literally write the question in Infobot that give me an average of the first 10 numbers. Now, those 10 numbers can be anything based on the use case that you have. Give me average of those 10 numbers, and it will be able to use the natural language, convert that into a SQL query, run through BigQuery where the data and the table is present, and give you a direct answer. And that is something that is very helpful, that helps not in efficiency, but also getting the data and the actual data that you need to make business decisions much faster. Both enterprise search and Vertex and Conversation are powered by the LLMs, and these are path of least resistance or the first point of entry that most of our enterprise customers choose when they are, starting their journey in generative AI. When they are starting to find that, what can be the path of least resistance, or the first thing that I can do to actually see the value that these LLM models are bringing to them. Um, Let's actually go through a demo and see that, how all of this is built. Let me share my other screen and let's go through that. Okay. Do you see my screen? Yes, perfect. So what you see here is a website which is essentially called Symbol. And what it is a website that think of it as, Auto Trader or a company which sells certified pre-owned vehicles. Now, until now, if you are looking to buy a vehicle or you're looking to buy an automobile, you need to know what exactly you are looking for. You are, the brand that you're looking for or the type that you're looking for, whether it is a sedan, whether it's an SUV. And you kind of have to keep in mind that, what year you're looking for. And then there are a lot of filters available in which you can, drag and drop and choose. But there is a lot of data on, the UI that you see. And there is a lot of information that you need to know before you can actually kind of even start navigating in the right direction for the product that you want. But let's see, what enterprise search brings to you. And that is that, say, for example, I am just looking for vans. In my head as a consumer, all I'm thinking of is that, okay, what if I want to buy a van? And what I do is I go to the Symbol website, and in their search, I just type a prompt or a question in natural language that what are some most popular vans that I need. And also, it can do a search using hashtag. So hashtags are really, famous now and common now with the generation that we have, and also the generation that is upcoming. So when I search for the most popular bands which are out there, now rather me thinking about which company, which brand, even makes vans and what kind of vans, if I just do a normal search that I have in my mind, it is able to generate those responses and give me the popular vans that exist in all the data that it has. It is not, very focused into a certain type of brand, whether it's, Ford or Mercedes or anything else. It is able to kind of give me all those answers, and it is able to use even hashtags and other things to retrieve those answers as results. Now, say for example, I saw the vans that I have, but now I'm thinking that what do I do with vans? Maybe I just need a car. It's a van or it's not, but the cars or vans that are good for camping because I want to go camping this year. So let's say I do an enterprise, I use enterprise search to do a search for that. Perfect. So now, as a consumer, I was thinking maybe van is something that I need. But if I search for the specific thing that I need, which is I need a car which is good for camping, it is able to give me the answer to that. Now, if you see, it is able to give me, the different recommendations that what are different cars which are good for camping, specific use case of mine. It is able to give me the price. It is able to give me a summary, and it is also able to give me different schedule on which on when I can actually go in and schedule a test drive. So it is able to do that. Now, thinking of let's actually try to schedule an appointment and see what else we can search here. Google is, really big when it comes to sustainability. We are very close in going, carbon neutral when it comes to all our data centers. So let's think about, electric vehicles that offer tax breaks. Let's search for that. Perfect. And we are also going to start using Infobot here. So perfect. When you are thinking of electric vehicles, of course Teslas come to mind, and not just Teslas. We have Chevy Bolt here. We have Nissan Leafs. So it gives you a bunch of options of all the cars and all the data that is available in Symbol website or like an Auto Trader website. So now let's see that, okay, I saw that this is Tesla Model 3. I really like the blue color. I have, summary of what that car is, if it's long range or standard range. And now I have specific questions about this particular car. So what I can do, I can go directly to my info board, and which is the chatbot here, which is incorporated within the same website. And let me ask a question. So I'm asking it a question that how much horsepower does a 2022 Tesla Model 3 have? It is able to give me an answer that, what the standard range of Tesla, what is the horsepower for that? It is also able to give me an answer for the long range one. Now I say, okay, that makes sense. What is the 0 to 60 time? I want to know that, how long does it take to go from 0 to 60? Now, keep in mind, I'm not asking Infobot the question of which car, which model, which year. I'm just asking a follow-up question on my previous question. And it remembers the context that I am asking the question for. So this is why this is multi-turn. It says that, okay, for 2022 Tesla Model 3, standard range goes from 0 to 60 in 5.8 seconds. And for performance, it takes 4.2 seconds. And then I say that, okay, this sounds great. I like what I see or what I hear. And now I want to know how long does it take to actually charge the car? Again, I did not give it any context of which car, which model, what am I talking about, and it is able to remember it from the last question I asked, and it is able to give me the answer. Now let's see how it can actually, help in automating tasks that once required human intervention. So say I say schedule an appointment to test drive Tesla Model 3. Perfect. So it says we have appointments available for 3 p.m. and 5 p.m. Which one do you prefer? I say I prefer 3 p.m. Amazing. So it sends a confirmation email to me, and my appointment is booked at this point. So this was the demo to go through that what is search, what is conversation, what exactly those tools are, how they are path of least resistance and minimal amount of effort required for organizations and for you out there to incorporate this in your current products and start actually seeing value from the LLM products. Now, let's actually go through the other thing that we talked about, which was productivity enhancement. And actually, consuming these LLM models that we have and how did we enrich these experiences in Google Cloud Console. So what you see here is something called Do It AI in Google Cloud. It is powered by the LLM, and this specific LLM is trained on GCP best practices, on Google Cloud best practices, on cloud documentation. And what it does is it brings assistant to your cloud users, whether they are application developers, they are security professionals, they are data engineers that are using the console. Do It AI is embedded and it is integrated into the GCP console. We will be going through a demo, and you will see, how it is incorporated and what it can do. Before we get there, let's just see a few examples that, what Do It AI can do as an assistant. So say, for instance, you are a cloud admin, you're a cloud administrator, and you are looking for ways to optimize your cloud spend. In this case, let's say it is Cloud SQL. So on the right-hand side on the slide, you see that you have Do It AI open over there as your chat assistant. And in natural language, you can literally write a question over there that how do I optimize my Cloud SQL spend? Now, rather going through different links, different documentation, different videos in order to even develop a strategy on how that spend can be optimized, you get direct results by just asking a natural language question there. And also, once you have determined that which way you want to go, you can again ask the same question on how to accomplish that, and it will be able to give you step-by-step instructions. So, as I said, that it can definitely act as an assistant to what whoever is there on the cloud users who are there on the GCP console on what they are trying to accomplish. One of the other feature that it has is the SQL explainability. Now, what that means is that, say, if I'm a data analyst and I'm inheriting a SQL code from an analyst that is maybe no longer in the company, and this particular SQL code is long and doesn't have a lot of comments on what exactly it is doing, Now I have to sit here and spend hours and hours to understand what exactly different, the code is, how it can be incorporated into what I am doing currently and with the other nested, code projects that I have. Now, what if I have an assistant who can actually explain the SQL query that is written in natural language to me so that my productivity and my effort goes from hours and hours to actually few minutes to understand what that particular code is doing? And that exactly what Do It AI does. You have a long line of code. You can highlight it. You just click a button, say explain this query to me, and it will be able to give that to you. I will be showcasing this in the demo in just a few minutes. Perfect. And then one more thing that I did want to highlight as a feature that Do It AI has is also about code generation and code completion. So now, as an application developer or as a data analyst, if I write say a comment, which is again natural language, that I want to be able to write a code for the most popular routes in New York City, and it is able to Do It AI is able to actually understand that, understand the context, and because it is trained on, with the large language model with GCP best practices and cloud technology, it is able to generate that code for me. And it is not just able to generate a very high level framework, again, based on the comments and the complexity of the comment. It is able to generate at least the framework, but if the complexity of the comment that we have written or the SQL code that we're looking to generate, it is able to actually write a code. And when you execute it, it is a valid code and it will be able to give you the results. So there are a long, a list of the features that Do It AI brings to you, Do It AI and Cloud brings to you as an assistant. These are the three that I did want to highlight. Now let's go through the demo and actually see that, how is this being incorporated in the GCP console. Now let me go and share my screen again. Perfect. So what you see here is called Google Cloud Console. On the right side is the assistant, which is Do It AI that I was just talking to you about. I asked Do It AI before, what are the typical use cases for connectivity tests. It was able to give me some results. It is able to kind of show me where it is getting those results from, so what the source is, and it's also able to show me some related content. I can ask questions here like how to create a table in BigQuery. And it is able to give me a very nicely written, succinct, accurate response on how I can do that, how I can create, a table in BigQuery, how I can do this using command prompt, what, different schema in it means, and it is able to kind of give me a sample query over here as well. So now let's go to the features that we were talking about and show you that how they can be, done and accomplished. So let's first go to the code generator that we were talking about. I have a comment here that says that using this particular data set, calculate the average trip length by the subscriber type and order it in descending order. So I go here, I highlight it, and it is quickly able to generate the SQL query for me. So say I accept the query that it generates for me and I run the query. And as you can see, the particular query is accurate, it's right, and it is able to actually go to the data set and go through the data set and give me the results right here. And all of this was done in sync in clicks. I didn't have to do anything. And the time that I saved as a developer or as an analyst who is, actually trying to get some very quick answers from, say, a table that is there, goes literally from 15 minutes, 20 minutes to a few seconds. Now let's see the other feature that we were talking about, which is explaining the code that is written that is being inherited by me as a data analyst that I did not write, and what I can do with that. Now, rather going through this is not that huge, but still big and good enough. Now, rather going through this entire code, what if there was a feature that, if I highlight it And I go all the way down and I click here and it explains what this particular query is. So once I did a click here, it says it was able to generate a query here that explained the intent of the Cloud SQL query that is highlighted for me. And over here, you can see that it can actually give you natural language summary of what this exactly code is doing. So all of this is to show and say that how Do It AI is helpful as an assistant. Again, this is a product which is embedded in Google Cloud, acting as an assistant, but it is running on a large language model that is specifically trained on cloud technologies, on GCP best practices, and it is there for you. And it is there for you to use in across your organization for different personas in how you can improve your productivity and be more interactive with Google Cloud. Now, let me pass it along to Anjali, who is going to cover the retrieval augmented generation part.
Thank you so much, Drishti, for covering the Vertex AI search and conversation and Do It AI. Now let's go on to retrieval augmented generation. With large language models being more improvised both quantitatively and qualitatively, and also they being more powerful, sophisticated, helping us in multiple different use cases, scenarios, and our applications, we have also seen that LLMs can provide us information that they are trained on or the context of the prompt that is provided to them. Since they are trying to be more helpful, they understand that the premise of the prompts is always true. This leads us to misleading content, inaccurate information, hallucination, or something as grounding. Now, grounding is the problem where LLMs does not have all of the context that it needs to have to provide us an accurate information to our requests. Thus, what all things happen? Say, LLMs do not are not able to provide us the sources of the information that it provides us, or they are unaware of the events that happen after the training which was done on top of it. So in order to tackle all of these issues and cater to all of the challenges, what we do is we go for RAG. Retrieval augmented generation patterns allows us to combine the context of relevant documents with the user's question so that the LLMs have all of this context and then generates the information from and generates the response from top of it, thus helping us stay grounded in factuality, getting relevant information and up to date information to what we desire. Thus, RAG is this process of injecting relevant supporting information to the prompt, to the user's question, and then combining both of this and then sending it to the generator, nothing but the large language model, and which would then be used to further generate the response to the user's question. With all of this context, we see its architecture. As we spoke about, there are these three components henceforth in the architecture. The knowledge base, nothing but the data stores, nothing but the external knowledge that we want our LLMs to respond from. The retrievers that retrieve this information from these knowledge bases, combines it with the user's question, and then provides it to the generator. So, three components: external knowledge, retrievers, generators. Thus, retrievers are that interfaces which takes in user's question as an input and provides the relevant documents which it has fetched from the external knowledge bases to the generators forward. And generators are nothing but our LLMs that form the response based on all of this context now to the user's query and sends them the response. So now we see a high level flow to all of this approach. The high level flow, as we know, the first part is nothing but when the user asks the query, when the user has a question which is sent back, which is gone to the retriever, and which is trying to fetch the information and send it to the LLM. Now, before this, we would form something as a database wherein we store all of our knowledge bases or knowledge or data stores or our documents. For example, we have our PDF, our unstructured information, which is available in our documents as PDFs. What we do is we chunk these documents create embeddings, that is transform this information into embeddings so that we build index out of it and then store it in vector stores, so that whenever the user asks the query, we again convert that query into a query embedding, so that we could use this embedding to do a semantic search on the vector store that we have built from all of the documents, to know what is the similarity or what are the similar documents to the user question, fetch those similar documents, and send them to the LLM to summarize. This is where we do. Thus, this portion could be built in multiple different ways. We could build our vector stores ourselves from scratch, maintain it, code it, take care of all of the different cases, or we could use something known as Vertex AI search, as Drishti was just going us through. What will Vertex AI search help us to do is it'll take care of all of our burden to prepare all of this. Wherein what we could do is we could create a data store in Vertex AI search, which it will store, wherein when we ask the question to it, it will create the embedding, fetch the respective information, do a semantic search, and provide us this information now. Thus, it takes us all of the process of building this ingestion process, and hence I could use it as soon as the user asks the question, and I could make use of this Vertex AI search. With that said, as we go on to the next question, next page, it leads us to guess how do we build the application. We use something as LangChain. LangChain is a framework that helps us to create application which is powered by large language models. Thus, it helps us to build applications that are context aware. That is, we provide all of this contextual information to the LLM. The contextual information could be provided as in terms of prompts, few short examples, or these documents that we were just speaking about. And it helps us to build applications that could be relied on, so that LLMs could be relied on to the response that they generate up for. Now, since it is a framework, it has lot many components, and as we can see on screen, it has components as chains, agents, memory, models, prompts, and indexes. To start with, chains allow us to combine different components together. So for simple applications, maybe just LLM suffice, but it is only for simple applications. For complex enterprise applications, we would want to uh, collaborate, or we would want to bring different components together, chain them together, be it LLM connecting to different components as databases, APIs, Google search, and other components, or it could be that LLMs connect to different LLMs, could be via sequential or orchestrated in multiple different ways, and so forth. That's where chains are useful for. Going on to agents, agents allow LLMs to be used as reasoning engines, so that they could decide what the next course of action would be, what is the sequence of actions could be taken. Then we go with memory. Memory allows LLM to have a buffer memory that allows them to preserve the context, which could be used by the models for multiple different tasks. Then we have models, nothing but our large language models, which could be text, chat, or multiple different ones. Then we have prompts, nothing but which could be used to fetch the required information to the way we want. And then is where we have indexes to provide more context, the documents, the indexes that are being created on the vector stores, and so forth. Thus, with all of this context and all of this information, we go on to see how do we create our retrieval based Q&A chains. So as we saw, LLMs provide chains to contain multiple tasks together. It thus provides us ways to chain the tasks of Q&A over a set of documents with something known as QA chains. Now, what does QA chains does is nothing but chain the retriever with the generator. As soon as the retriever fetches the information from the configured knowledge bases, it provides that to the generator. How does it provide? It provides it after it has done the semantic search, it has fetched the relevant documents, and then it provides to the generator to generate the final set of responses. Everything happening seamlessly. What do I just need to do is I just need to configure my retriever with my knowledge bases, and the LLM that I'm going to use. How many different kinds of LangChain retrieval Q&A chains are available? There are three different kinds. One is retrieval Q&A to provide me the response to the from the set of documents that I desire for. Retrieval Q&A with source chain providing me the source document from where it fetched the response as well. And then conversational retrieval chain, providing more of chat like experience, wherein I would just not be limited with one question, but I would want to converse it further so that I can ask one question, then build on that, and so on and so forth. Now, with all of this, we just look into the considerations that we need to have with retrieval augmented generation chains. One of the consideration is the length of the documents. We would not want to confuse the LLM with large amount of information, that we have many documents which are shared, and it is again then going over all of the documents to fetch the relevant information. We would not want to confuse further. So it is very important to know the length of the document chunk that we need to provide the LLM up with. We would also not want to exceed our prompt length, so that it is within the limits could be provided to the LLM, and it takes in that and generates the response. Consequently, choosing the chain type, there are again different kinds of chain type. How many documents do I want to provide? Do I want to provide all of the different documents to the LLM, which is known as stuffing, which is a simple approach, or do we want to further refine? We would want to further rank. I want to ensure that only the most relevant documents are shared, as we go for different other types, which is map, reduce, and refine. And with all of this context, with knowing retrieval augmented generation, knowing its architecture, knowing the framework that we are going to use to build it, knowing the component that we are going to use, which is nothing but retrieval QA chain, and having some considerations, we go on to see a demo as well. The demo that we are going to see is stored onto the GitHub generative AI of Google Cloud Platform, which is over here. It has all of the different code required to create this application. Now we'll go through all of this. How we could run it? We could run it in Colab. We could click over here and could run it in Colab, or we could also run it in Vertex AI Workbench as well by clicking over it. I'd run it in Colab itself. Now, as soon as I go over here, I'll run it in Colab. It renders the same document in the code. Now, first thing first, which is I build my notebook. That is, I set up my environment. That is, I install my libraries. I'll install my libraries for Vertex AI, for LangChain, for Discovery Engine, and I install all of my libraries. For the purpose of demo, I've already done and have restarted my runtime. What I do next is I authenticate myself. Now, for the knowledge base, as we saw, I'm going to use Vertex AI search. Henceforth, I would want to authenticate myself for all of my credentials. I have authenticated myself so that I could connect to the Google Cloud as well. What I do next is I configure my Vertex AI search. Now, before configuring it, I'll have to first build it. So, how and what are the knowledge bases? What are the documents that I'm building up with? Is I create a data store of Alphabet's investor reports, which are available externally, publicly as PDF documents. So, what I do is I create a Vertex AI search data store. How do I do is I go nothing but to Google Cloud Console over search and conversation, and I create an app. As simple as I create an app. There are different kinds of apps which are available. As Drishti showed, we have search apps, we have chat app, and so forth. So I create a search app. On doing this, I provide the different configuration, different enterprise edition features, and so forth. I provide an application name. Say, for example, I just provide a name as demo, and I name it as, since I am gonna be doing for Alphabet, I provide the name and I say continue. I select my region as well. Now I create the data store. Data store is nothing but a store that will contain my data. Now, since it is PDF documents, it's unstructured information, it's not a website, it's structured, so it's not BigQuery. I'll store it in cloud storage. I have already stored and I've configured it, and essentially I have already created my application, which is this. If I see my application, if I see my data store as well, the data store which I have built on the cloud storage, which contains all of the Alphabet's investor PDF documents, it gets created as this. All of the documents are available with an ID, with the URL as well. So I get to know that I have trained it on 2022 earnings transcript, the annual report for 2021, 2022, and 2020. These are the documents that I have indexed it over. Now, once I have done this, my knowledge base is ready. I go to the next step. So I connect it. I provide that this is my data store ID. I took my data store ID that I just created. I provide my project ID, and I say that the large language model that I'm going to be using is. So I have provide this information. Consequently, as we saw, there are three different kinds of chains available. First, I'm going to go with retrieval QA. Just provide me the information. Just provide me the answer to the question that I'm asking. Simple. Again, as said, retrieval Q&A. I'll configure my retriever. The retriever that I'm going to use, since I'm connecting to my Vertex AI search, I have Google Vertex AI search retriever already available as a part of LangChain retrievers. What I just do is from LangChain.retrievers, I import it and I configure it. I configure it on my project ID, my data store ID, and further other different parameters. Parameters such as how many documents do I want to share? As we discussed, we have to be cognizant about the fact that it has the relevant amount of information that I need to pass. So all of these parameters, I configure it in my retriever. Then is where I build my chain. Nothing but wherein I'll bring everything together. What I do is I have my search query, as simple as who is the CEO of DeepMind. I use my retrieval QA chain to provide three components, my retriever configured with my knowledge base, the chain type. Currently, I want to provide all of the information that I've retrieved, the chain type as stuff, and then my LLM, which is nothing but my PAM model. What I do is I just execute it. It fetches this information and gives me the response after providing it to the LLM. Now, what I do next? I want to see what were the documents which were pulled as a part of my query. How do I do this? Is as simple. The same retrieval QA chain. What I get is as a part of the result, I just not get the result. I also get my source documents, and I can pass all of the source documents that the retriever retrieved for me. So I can validate which were the documents which were retrieved. But more specifically, for example, I want to know where this answer was specifically retrieved from. What I do is I then use retrieval QA with source chains. It will provide me the source information as well. So henceforth, the same thing. Nothing but I just changed the chain. Everything remained the same. Components remained the same. Retriever, chain type, LLM. As I run it, after I fetch the response, I just not get the answer. I get the sources as well. Once I've got the sources, I can validate. Consequently, I go on to the next step, which is conversational retrieval chain. I want to build my application which I can provide to my user, for example, for different use cases as like say employees wherein they are asking their policies, company policies, or for example, medical insurance queries, or for example, privacy policies or different ones. I might not just be limited to one question. I would have further more questions that I'll build as and more responses that I'm receiving is where I get conversation retrieval chain. Again, what changed is my retrieval chain. I pull it, and since it is a retrieval chain, which is conversational retrieval chain, I need to have some memory which could preserve the previous context. What I do is I use this memory component as we had seen it in the LangChain components, which will preserve the context. Then I create my conversational retrieval chain, provide all of this information. Same thing, retrieval, LLM, and here memory because I want to have a chat like interface. I provide my search query. It fetches this response from the document, and it's an exact revenue in 2022 in millions. But now, then I build on top of it. What about the cost and expenses in 2022, 2021, and 2022? Now it understands I'm talking about alphabet. So here is as soon as I trigger, I retrieve this information. It provides me again the exact information that it has retrieved from the document for the cost and expenses. The LLM has retrieved. Consequently, I ask it further, is this more than 2021? So that it compares, it gives me the response, and I could use it. As I could go on and see the document, it certainly is that the alphabet's cost and expenses in 2022 were more than 2021. Correspondingly, there are other configurations as well. Conversational retrieval chain ensured that it has the context preserved, but it was just the chain which has. What I could also do is there is another retriever, which is Google Vertex AI multi-turn search retriever, which also has context preserved. So what I can do is I can use the chain along with this retriever so that I have context preserved very well, and then it provides me the response. Nothing else changes. Retrieval chain remains the same as I used earlier. Only the retriever is changing, which again is my Vertex AI multi-turn search retriever. I run it, the same process, provide all of this information. It retrieves the information. Get it generated as I was getting it earlier. All of the similar things. The query, the responses remains the same. I get much more contextually aware information, and I run this as well. Consequently, there is this last piece showing us that once we do all of this, we could also change the default LangChain prompt so that, for example, as a part of the retrieval QA chain, it provides me a prompt which is default prompt. But I do not want to go with the default prompt. I want to say that if you do not find any conversation, or if you do not find any documents in the knowledge base, do not provide any response. So this is a specific, this is a custom prompt. I could change it. It's a very simple way to change it. What I just do is I just create the prompt as we had seen again in the line chain components. I just use this, provide it as a part of my chain as another argument, and my work is done. Now, as we can see, the prompt that is being used is the one that I provided. Consequently, now if I ask this question, were the 2020 EMEA revenues higher than 2020 APAC revenues? As per the document, it's yes. It is. It were more. And what is the information which is being used is over here. Now, with all of this seen, with knowing what the concept of retrieval augmented generation is, to seeing everything over and seeing the demo as well, I would like to take through the question answers now. Yeah. So there are multiple different questions which are present. I'd like to take one amongst it, wherein is Vertex AI search available on all language? Or what are the different languages that Vertex AI search and conversation are available? So as of today, Vertex AI search and conversation supports 10 languages, say English, Spanish, German, French, Italian, Hindi, Dutch, Portuguese, Danish, and Swedish. All of this is available in the public documentation as well and could be referred anytime. So, yep, and the list is going to go further, but as of today, it's these 10 languages which are supported for this. Drishti, if there
Perfect.
is any
Yeah.
that you'd like. Mhm.
Anjali, there's a follow-up question to that as well, that what type of data stores are covered for Vertex AI conversation? So I would just like to mention that Anjali just showed us the UI that for Vertex AI search and for Vertex AI conversation, there are three kinds of data stores available: the website, structured and unstructured. Websites, there is a box in which you can, incorporate all the websites and web pages that you wanted to include. And there is another box in which you can say, do not exclude this particular web page. So that itself is available as a feature when you're creating that particular data store. When it comes to unstructured data store, literally it's a cloud storage bucket. So it's a blob store. So you can map it to that. When it comes to structured, to create that particular structured data store, you can, either put it in BigQuery, or I believe there is an option to click on Cloud SQL as well. So those are available over there too. All right, perfect. So I think with that, this ends our series today. So thank you so much for being here with us, and it was very lovely to be with you to help you navigate the path, and looking forward to interacting with all of you soon.
Thank you so much.